Yeah, pretty long title. I'm glad it still fit on the slide here. Tenant autonomy and isolation in multi-tenant Kubernetes clusters. Glad that all of you could make it. It seems like we got a packed room today. Who's operating multi-tenant Kubernetes clusters today? Quite a few of you. Okay, hopefully it'll be more after this talk, right? Little bit of background. We are a company called Loft Labs, but you probably know us more under the term vCluster. It's an open source project we started in 2021. Gotten quite some, GitHub stars and pretty vibrant Slack community. Feel free to join slack.vcluster.com. There's about 40 million pulls of our Docker image. So it's about 40 million, virtual clusters that someone created at one point in time. That doesn't mean they run, all together at this moment, right? Sometimes you only spin them up for 10 seconds. You destroy them after a couple of experiments. There are a couple of Fortune 500 companies using our technology. You see here, that's the companies that I can't put the logo on the slide, right? So I gave you a brief description: chip manufacturer, global Big Four, global accounting firm, electronics giant. You can probably imagine who these companies are. We're a startup. We recently raised a Series A by Khosla Ventures, 24 million. Very excited to dive into the topic of multi-tenancy today. We're going to talk first about why multi-tenancy in the first place, right? Obviously, there seems to be a need for this. Otherwise, you guys wouldn't have shown up for this talk. But we'll see what is one of the core motivations for going multi-tenant. Then we're going to talk about how to isolate tenants. We're going to talk about how to ensure fair use. And then we're going to talk about how to enable tenant autonomy. So it's a packed schedule. So let's get started. Cloud spend is on the rise. If you're looking at the latest Gartner studies, $679 billion of cloud spend in 2024, that's quite a large number. But what's even more impressive is the growth rate. 20.4% increase from 2023. That's huge, right? So cloud spend is on the rise. And when you look at the latest CNCF FinOps microsurvey, 70% of organizations identified Kubernetes as one of the bad guys out there, right? What's up with Kubernetes, right? Leading to a surge in spend ultimately. So that's obviously a problem, right? So let's take a look at this. If we look at the standard, Fortune 500 company out there, they create a lot of clusters, right? For those of you who are already operating multi-tenant clusters, good for you. You may be a step ahead. But a lot of companies create a cluster per team, sometimes a cluster per customer if they have a managed service, sometimes a cluster per environment, right? The biggest deployment I've seen is over 3,000 EKS clusters, right? That's a lot. And then they have more in the private cloud too, right? So there's a lot of Kubernetes clusters out there. So some of these companies have hundreds or thousands of clusters. And when you look at these clusters, right, the first thing you notice is you pay a fee per cluster, especially in the public cloud, right? In the private cloud, there may still be overhead for running these, master nodes as well, right? That control plane needs to run somewhere. That's compute, right? But in the public cloud, there's pretty much the same price for each of the cloud providers. I know Google had no cluster fee in the early days, and then they pretty quickly realized, these clusters are expensive to run, right? We should probably add a cluster fee as well. So today we pretty much have the same cluster fee in all cloud providers. Then we're looking at the platform stack, right? And you see in this diagram here, there's a lot of duplication, right? Having 100 clusters means you probably have 100 times Istio, 100 times Vault, 100 times OPA, 100 times Cert Manager, right? That's a lot of components running all the time, right? It's a lot of management overhead. TCO is pretty high for this. So pretty clear we need multi-tenant clusters, right? That would be a much, much more interesting, cost-efficient approach. So we're going to talk about how to establish workload isolation when you're going multi-tenant, because that's obviously important. You want to keep things separate, right? Obviously, separating by cluster, there's pretty natural separation, right? It's completely separate, which also has a problem. You can't share anything, right? So if we're going to a multi-tenant cluster now, we can share things, but we still need to keep things separate. And then we need to ensure fair use in these clusters. And then last but not least, we got to take care of tenant autonomy. If I give you a cluster, then you're pretty autonomous in that cluster, right? If I give you a namespace in a shared cluster, you may not have as much autonomy and control over that cluster. So let's get started with isolation. The first topic we have to talk about is pods, right? One of the core objects in Kubernetes. Without pods, I don't know why you're using Kubernetes, right? Pod security standards is something to definitely take a look at. I put a couple of YAML snippets on the right-hand side to illustrate how to set certain things up. What we essentially want to do is restrict access to the host, right? So wherever your containers are running, you don't want them to mount anything from the host typically, right? Because that's bad, because there may be other containers running on that same host, right? Host ports, similar topic, right? You can run out of them pretty quickly, so you want actually folks to architect the applications differently. You want to prevent any kind of privilege escalations, and there's a lot more things to cover in terms of workload isolation on the pod level. Last but not least, you may want to introduce custom policies, right? To essentially say, hey, our pods need to be labeled in a certain way, right? Or we're going to do cost tracking, so we want the tenants to make sure they are putting a label on each one of the pods that they're creating, so we can track that and charge them back, right? There's a whole bunch of these topics that you can achieve with tools like Policy Agent, Kyverno. We launched a tool called JS Policy. That was just a weekend experiment, but feel free to check it out as well. It's the idea of how to create policies with JavaScript to make things a little bit simpler, right? Next thing we have to take care of is network, right? We obviously don't want everybody in a multi-tenant cluster to talk to everybody, because you may not secure your applications, right? You may secure them against an ingress, and you may have rate limiting in there and a lot of things. But within the multi-tenant environment, if everybody runs in the same cluster, you have to worry about internal traffic, right? So the first thing we would do with a network policy is we would deny everything internal. The reason why we do that is we don't want anybody else that runs in that same cluster to talk to our applications, right? Network policies don't work on a deny basis, they work on an allow basis. So we kind of have to invert the statement, right? So essentially we have to say allow everything, which is that CIDR block of IPs that you're seeing up there, 0000/0, right? We allow everything. And then we have to say accept all the internal IPs, right? So we're listing all the internal IPs here. Obviously, you can have different, subnets in your IP where you're saying, hey, this is the IP range we want to lock in. But this covers a pretty broad range of internal IPs typically that folks are using. Then you want to typically allow traffic within the tenant namespace, right? Because if you're in one namespace and you're locking your tenants into this namespace, they may have 5 pods and they need to talk to each other, right? So obviously we want to allow that. So we're saying namespace selector, if the label of that namespace matches tenant 1, we're good to go, right? It's as easy as that. The next thing to think about is DNS. You may want your tenants to reach the internet. You may not, right? You may want them to resolve DNS within your company network or outside with google.com, etc. So we do want to open up these ports. 53 is typically the DNS server ports, so we're going to add them to this network policy and allow that. But obviously there's other options. You can obviously run your own DNS servers on different ports if you really want to do that. I'm not exactly sure why you would, but this typically is that statement that you should add for this. And then last but not least, it may be a good idea to actually let pods talk to the Kubernetes API, right? That may not be necessary for every one of your tenants, but if you do, this is the way how to do that. I was not able to find a way to programmatically fill in that kube API variable here, so I just put it as a variable in here. If you do have a programmatic way to do that in Kubernetes, let me know. If nobody can come up with anything, this may be an interesting PR against Kubernetes network policies, right? Just as an idea, right? In terms of nodes, right, that's the next level, right? So we have pods restricted to not run as privileged pods. We have some policies, right, in place for these pods. We have the network isolated. Let's take a look at the nodes next. Obviously, what you can do in these pods, and you can enforce this with things like mutating admission control via OPA, etc., right? You can say, we're going to statically assign nodes, right? Node name is X, right? We're clearly saying this tenant goes to this node, very static assignment, right? That's the most trivial way. The next level would be saying, hey, we're creating node pools for different tenants to keep them separate, but it's not one static node, right? We don't have to make a static assignment, but instead we're saying, hey, we're going to select these nodes, and we're essentially saying, hey, this is our node selector for tenant 1, right? Please use these nodes only, and then tenant 2 gets a different set of nodes, right? Different node pool. Then we can obviously use on-demand VM provisioning, things like Kata containers, nodeless Kubernetes, right? There's tools out there that essentially say, hey, we're spinning up nodes for each one of your containers. And that is a pretty interesting approach, these micro VMs that you can spin up with these kind of tools. So you're saying, hey, I'm not going to bother with statically provisioning nodes and creating and configuring node groups because I'm not going to get it right anyway, right? So let's just use one of these tools to dynamically spin up these micro VMs, right? And it may take a teeny bit longer to maybe launch a container, right? But you're having it pretty right-sized in that moment. And you obviously have pretty great isolation. You know, every one of these pods runs in its own micro VM. And then you can go full serverless. And you're like, I don't want to take care of this at all, right? And then you can use things like virtual kubelet. You can use EKS with Fargate as a background, right? As a tool in the background to launch your workloads, right? So you're saying, hey, I don't care about nodes at all. This should all be serverless. GKE Autopilot is another mode. Let's talk about fair use in these clusters, right? That's the next thing we have to take care about. We want to really make sure that our tenants can, in certain limits, do a lot of things, but we have to make sure that not one of our tenants is consuming the entire cluster, right? So if you have one tenant that wants to deploy, 1,000 pods because they have this interesting experiment that they want to run, that may not be ideal for everybody else in that cluster, right? So we need something like a resource quota. Resource quota namespaced object, so pretty nice. We can scope that to the namespace we're handing out to our tenants. You can see here with the count prefix, we're essentially saying, hey, 20 pods max, 100 secrets, 100 config maps, etc. It's pretty reasonable to have limits like this for pretty much all of the objects in your cluster, because and we had a really interesting meetup with Adobe, I think 2 years ago or so. Where Mike from Adobe showed how they are using, as an experiment and kind of like a test, a faulty controller that creates, thousands of secrets per second, right? Well, this would have prevented it, right? This would have kind of put an end to it because you can actually bring a cluster down if you're creating tons of secrets, tons of config maps, right? So you may not think this is a huge attack vector, but it's actually going to increase that load on that etcd and on that Kubernetes cluster quite a lot if you have these objects completely unlimited. Then obviously you can add custom resources to this as well, right? Something like virtual service and Istio may be a good idea to limit that as well if you're limiting services in the first place. Node ports, load balancers, right? There's so many objects in Kubernetes, the list is getting pretty long, and then you can add hardware resources to this. This is by no means exhaustive. There's probably going to be a lot more resources in your clusters that you actually want to limit. And again, it's like carefully considering, hey, let me list the resources in my cluster and see what we actually need to limit, right? You can see here requests and limits can be set separately for things like CPU, memory, storage, etc., right? Heavily recommend setting those things. The next thing I would recommend setting up is limit ranges, right? Limit ranges, namespace resourced as well. You can ensure that your containers, as in this case, have default limits and default requests, right? Because a lot of engineers, when they deploy things, you give them a namespace, they may not think about this, right? And as a platform team or as a central IT team that manages Kubernetes and hands out these namespaces in a multi-tenant cluster, you probably have an idea of like minimal requirements for average applications in your company, and obviously it may vary, right? So it may make sense to be a little bit cautious on this end, right? And find like a rough estimate that works for a lot of teams, for those folks who have no idea what to use here, right? The next thing you want to do is probably define minimum and maximum ranges, right? That's where the name limit ranges comes from, right? So you're essentially saying, hey, minimum, maximum resources that need to be defined on our container is pretty helpful. And then ultimately, the question is, what is the unit of segregation here, right? We've seen all of these resources, they're essentially namespace resources, right? So, we've seen the network policies, we've seen the limit ranges, we've seen the resource quota, right? All of these are namespace objects. So really the namespace is the canonical unit for us to say tenant equals namespace, right? And many of these controls are namespace based. And namespaces are great because namespaces give you a great way to segregate things in a cluster, and they prevent naming conflicts, right? So if I have two tenants and two different namespaces, they create a service, they create a resource, virtual service, those kinds of things, right? They don't need to think about what the other team is calling it. They don't need to prefix everything with their specific team name, right? That is a great thing that namespace offers out of the box. A lot of other tools are also allowing you to easy filtering by namespace, right? If you think like, Grafana dashboards and stuff like that, having a selector per namespace, pretty easy to implement these kind of things. A lot of tools come by default with a way to manage namespaces. I know like Rancher, for example, and their projects based on namespaces, right? Namespace is a great object to essentially say, hey, this namespace is a tenant's realm, right? You can do whatever you want in that namespace, again, within the limits that we just defined, right? But for some of our tenants, and that's really where the argument around tenant autonomy comes from, a namespace may not be enough, right? And that's pretty problematic because what can we do next, right? Well, how about multi-namespace tenants, right? That's going to alleviate some of the pain, right? So we're essentially saying we give one tenant 5 namespaces because they want to architect the application in a way that certain components, certain microservices run in different namespaces. So we'll just give them 5 namespaces, right? No problem. Well, it does increase the complexity a lot, right? Because previously we had a pretty standard configuration that we could just push out in all of these namespaces, right? Now we have to have a configuration per tenant, right? Because we are essentially needing to say, okay, like we're gonna somehow divide this up per namespace. Like think of a resource quota, think of a limit range, right? You're kind of thinking about these things and they're locking things into a namespace. Suddenly you have to say, okay, what is my quota across 5 namespaces? Am I just gonna divide the number by 5? Right? But that may not reflect the reality of our tenants, right? And then am I giving that tenant 5x of what I gave the other tenant because they need 5 namespaces just because they want to segregate things, right? That's pretty difficult as well. So the complexity really grows with the number of tenants and the number of these kind of exceptions that I need to make, right? And then you have another big problem, and that is access to cluster-wide resources, right? So when you're thinking of Kubernetes, you're thinking of tools like Argo CD. Well, Argo CD needs CRDs. So if your tenants want to experiment with Argo CD, right, and set that up as their CD tool, they're going to be out of luck because they can't deploy that to their namespace. I mean, I guess they can deploy the Argo pod, right? But like without the CRDs, that controller, can't fire up. So that's pretty problematic. So what usually happens when you start doing namespace-based multi-tenancy is tenants are going to come back to you. And they're going to say, well, can you set up Argo for me, right? Because I don't have the permission to do it, right? And then you have to decide, do I want to maintain that for my tenant, right? And then you also have the problem of, I have 3 tenants and they want 3 different versions of Argo. What do I do now, right? Do I put them in separate clusters now? It's all very problematic, right? You can probably guess where we're heading on this journey. How about cluster per tenant again, right? That is obviously the option that would solve all of these problems, right? Then people have full control over cluster-wide resources, CRDs, controllers. They can set potentially control plane flags. They can tell you, hey, we want to use this alpha beta feature in Kubernetes. Can you enable this for us? They can pick their Kubernetes version, potentially even their distro, depending on what you're doing. So cluster per tenant seems like a great model. But let's not forget, price tag's pretty heavy for this, right? So we're back to square one, right? And that's obviously not great. We're trying to get to a better solution here. And that's essentially why we came up with vCluster in 2021. We launched it as an open source project to kind of say, okay, namespace-based multi-tenancy is the standard for multi-tenant Kubernetes clusters, but it has these limitations. So how can we overcome these limitations, right? What we're essentially doing with vCluster is we launch we tell you don't hand out, that cluster's API server directly to users to talk to. Instead, launch a control plane that runs in a container, right? Containerized control plane. Launch a pod in that namespace, and then make that pod accessible to your tenants. So you have some kind of load balancer or some kind of ingress, right? For folks to now, and they have regular kube context and they run kubectl commands, right? It's a fully fledged cluster, right? But it actually runs as a container inside a namespace, right? So you feel like you get a full cluster, but you really don't. You're really just running in a namespace, right? And when you're looking at this, architecturally, that is really nice because it allows us to run certain things in the shared underlying cluster. So we can share things like an Istio and a cert manager, right? Our Datadog agents are deployed centrally to this cluster, right? And go on every node. We don't have to, deploy these tools per vCluster. We can run them in the host cluster. And then the vCluster becomes essentially the boundary for, what your tenants are going to deploy, right? And that's pretty neat. When you're looking at this model, right, obviously you have fewer real clusters, which is the goal of multi-tenancy in the first place, right? We're reducing the number of clusters. You have that lightweight layer of virtual clusters. And then you have that shared platform stack, right? That allows you to really say, okay, this is the standard tooling we provide as a company. This is the golden path. But if you want to deviate from the path, right? And you want your own, maybe Argo CD version, or you want to layer your own custom OPA on top of this, right? Then you have 2 admission control loops, right? You can do that now, right? So you're really giving a lot of autonomy to the tenants, but you're sticking very closely to that namespace-based model that I was just describing, right? It's an addition to namespace-based multi-tenancy. Obviously, that saves a bunch of cost. And it's a really exciting model because you give a control plane per tenant without giving a separate cluster per tenant. That means your tenant have full cluster admin access in these clusters. Obviously, you can narrow them down as well if you really wish to do so. We've seen that too. But the interesting model is, we've seen, vCluster is just a deployment, right? It's a deployment and a service, and in the easiest case, you just do port forwarding to that service. So sometimes what we see is if people have namespace-based multi-tenancy in place and tenants are limited, these tenants sometimes figure out, well, I can create a deployment and a service, so let me spin up this vCluster thing, right? And suddenly you feel like you have your own cluster, right? Obviously, it's much better if the company says like, hey, we're handing this out in a standardized way. We're making sure these Kubernetes versions are actually being upgraded, right? Because if an individual engineer does this, deploys this to EKS, you may have an unpatched Kubernetes version running. And, in the worst case, there's an ingress pointing to that is publicly accessible. Oh gosh, right? That's not super ideal. So that is something that the company wants to get ahead of typically. But by providing something like this and say like, hey, we have a model to deploy vClusters to namespaces and elevate privilege for those folks who need access to controllers, who want to do things across namespaces, we can stick to the namespace per tenant model and keep it very simple in our multi-tenant clusters. And at the same time, give the best possible experience to everybody, right? And the only overhead you have is you have that lightweight vCluster pod, right? We did the math in EKS at one point. It costs less than $90 to run vCluster for an entire year, right? That's a very small ticket for, unleashing a lot of autonomy for engineers. vCluster is a certified Kubernetes distro, so it should behave like any other Kubernetes cluster. That means when I'm moving my workloads, right, I'm changing my CI pipeline to now talk to a vCluster instead of the namespace directly, nothing should ultimately change. Other than, obviously, I can create 100 namespaces and I can, do a lot more things in that vCluster than I could in the regular namespace. You can deploy vCluster via CLI. I put the CLI command over here, and everything you just saw in terms of resources that we were just creating, you can do that by simply enabling, network policy true, resource quota enabled, limit range enabled. That's a lot of the resources we created earlier. We do create a couple of other resources by default, and you can tweak them, obviously, right? You can customize them as you wish. But we have this, vCluster YAML, which is ultimately kind of a values file for a Helm chart, right? So ultimately, we're just, creating that stateful set by default, because the vCluster does have state. You can also deploy it as a deployment if you want it entirely stateless, and have SQLite as the backend, right, on the ephemeral storage of the container, and then, you restart the pod, you have a, clean cluster again, right? Pretty straightforward to spin up these vClusters. The next level would be attaching a persistent volume, making a stateful set. That's our default setting. Storing things still to SQLite. Somewhere you need that state of all these virtual objects that people are creating needs to live somewhere, right? SQLite is the default for this. And then obviously if you are taking it up a notch and you're saying, hey, we want to run vCluster in production, no, production multi-tenancy, one, vCluster per customer, then, SQLite may be limiting for you, right? Ultimately, it's a single file database, right? So if you have a lot of requests going on a vCluster, it's going to hit a limit at a certain point in time. And then you can just switch over to etcd, right? You can run an etcd cluster. You can run a feature we call embedded etcd, where we actually fire up an etcd in that same container. And then you can scale up that container horizontally from 1 to 3 to 5, right? And it becomes a HA etcd cluster without you having to manage etcd. And then ultimately, you can connect any relational database, right? So you can say, I'm going to store the state in, my SQL database or in AWS RDS, and I don't care about the database at all, right? I'm connecting that database server. Each vCluster gets its own database with limited credentials to write in these tables, right? Pretty straightforward. Besides deploying via CLI and Helm, you can obviously deploy the Helm chart via Argo application sets. We have a Terraform provider and a whole bunch of other offerings, and recently launched a Rancher integration as well. So, for folks that are Rancher-based, you get a couple of buttons in the UI for folks to just say, hey, spin up a vCluster. What it does, it creates a namespace, it adds it to a new Rancher project, deploys a vCluster inside, and adds that as a connected cluster in Rancher, so that folks can now, see that project, see that namespace, and have a new cluster in Rancher, right? Because mentally in Rancher, you have two models, right? You have namespaces, you have clusters, and again, a vCluster is somewhat in the middle. So we show you both, right? And yeah, a lot of these isolation best practices we talked about are baked into vCluster by default to give you a good starting point. But again, everything can be tweaked. It's Kubernetes after all. And yeah, that brings me to the end of the talk. We do have a booth out there, so look for the big orange vCluster sign if you want to have a more in-depth chat about how vCluster can be added to your stack. And as I said, it's open source technology, so you'll find it on GitHub. If you want to check it out, feel free to add me on LinkedIn and shoot me a message if anything else comes up. And I think I'm pretty much in time for us to still have a little bit of a Q&A. So happy to answer any questions. Oh, and I think I have one more slide. Yeah, we're also a pretty fun team to be around, and we're heavily hiring at this point, expanding the team. So if you're excited to join us at various KubeCons in different locations all over the place, head to our website and check out our careers page. Yeah, any questions at this point?
Thank you, Lukas. This was pretty exciting, and we have like 8 or 9 questions already. So
oh, wow. That's a lot of questions.
Yeah. If you have time, let's go through all of them. Is performance affected if I run 100 pods inside a vCluster versus running on a dedicated cluster?
Yeah, that's a good question. I should have brought an architecture slide as a backup for this. The way it works is, so the vCluster is a regular control plane, right? So it has an API server, it has a controller manager, it has this data store that can be, as I said, SQLite, etcd, external RDS, MySQL database, right? And then usually, you would have a scheduler as well, right? And what the scheduler would do is scheduler is aware of your nodes and says like, this pod goes in this node, right? What the vCluster has instead is the vCluster has a so-called syncer. And what the syncer does, it connects to the underlying cluster's API server and to the vCluster's API server. So it talks to both, right? And when we see a pod that needs to be scheduled, what it does, it copies the pod down from the virtual layer, right? From the virtual etcd or virtual SQLite, to the real cluster's namespace, right? Obviously, it maps 100 namespaces to one namespace, right? So there is some, renaming of these pods happening. The original names are still in labels. So you can still trace things back to how was this named in the vCluster, what was the namespace inside the vCluster in the virtual context. But because we do the essentially copying down, the underlying cluster scheduler is now going to schedule this pod, right? And we saw earlier we can now restrict things, on certain node groups, etc. Have certain, tolerations and affinities, on these pods, right? But because the underlying cluster runs your container, it would be as if you would have just run kubectl apply, pod YAML on that namespace, right? But you may have actually not created a pod directly in that namespace. What you did in the vCluster is you created a stateful set. And that stateful set, the replica controller created 3 pods, right? And then these 3 pods got copied down to the underlying cluster. So in the underlying cluster, we don't see the stateful set, but we see these 3 pods being scheduled, right? So there's essentially no performance hit. The networking, the storage, everything is handled by the underlying cluster, which is pretty neat because all the network policy we saw earlier, OPA, right? Any kind of restrictions you currently have in place that limit your workloads and that you're setting up for namespace-based multi-tenancy, they are still in effect. The only thing you're doing is you're giving people a virtual space to do things more than pods, right? But in the underlying cluster, they essentially only need the permission to create pods. And we do also copy services for DNS-based communication. But that's pretty much it. All the CRDs and high-level objects live in the vCluster.
All right. Next one is about the shared tool stacks. So if you have a monitoring agent running on the host cluster, how does that interact with the vCluster?
So when you're sharing tools like an ingress controller, as in this question, so let's say you have like Nginx ingress, right? And you're creating ingress resource, right? You can enable syncing. As I said, there's a syncer, right, that copies the pods down. You can also enable syncing for ingresses, and that way use the underlying cluster's ingress controller. But your tenant can also say, I'm running my own ingress controller, right? It can be a mix and match. And obviously your tenant needs to have the permission to create a load balancer, right? In order to deploy their own ingress controller. But yeah, I think the beauty of this is you can say, hey, this is our company standard for how to do things. And if you just want the out-of-the-box golden path, right, just create an ingress because we enabled ingress syncing for your virtual cluster. And the underlying cluster's ingress controller that we maintain centrally as a team will take care of this for you, right? But if you have tenants that are more sophisticated and say, hey, we need our own ingress controller, different version, different spec, right? Then they can roll their own. That's the flexibility between sharing things versus having things separate.
All right. How does Argo CD and Flux seize vCluster?
So if you have any of these tools, you give them a kube context, right? You have some kind of secret, right? Where they read the credentials for us. So, what is the API server address? What is my service account, right? Or, what are my other credentials to access this Kubernetes cluster? And since the vCluster is a regular Kubernetes cluster, it works exactly like that, right? You create a kube config for your vCluster, you hand it to Argo CD, and they essentially deploy to it. If you have Argo CD in the vCluster, obviously, it's going to use that vCluster's standard access mechanism, right? It has the Kubernetes service, right, that points to the API server from within. You have a service account in that Argo CD controller pod, right, that has permissions to access this Kubernetes cluster. Pretty straightforward. No difference to a real cluster.
Just a quick one. Can you run a vCluster in a vCluster?
You can, yeah. We actually have a YouTube video about this. It's called vCluster Inception. I think we went down like 3 or 4 levels. We've never tried how deep can you go, right? Like with every level you go down, as I said, because the syncing mechanism, ultimately when the pod gets started, there's no performance impact, even if you go 100 layers down. But it may take a while till everything is reconciled, right? So for that pod to actually be scheduled on a node, it may take a couple minutes.
But then how do you know when are you on the real cluster? Like
you'll never know.
It's impossible.
That's the whole point. You should never know, right?
You never know. I actually seen a demo like that. There was always like one layer up on, I think it was some conference.
Yeah, we do that in demos too. Yeah. When we demo our own product, we always run it inside a vCluster, and then we create other vClusters to launch vClusters in, right? And it's funny, at the end of the demo, we're always saying like, yeah, and this was all in a vCluster. And by the way, that vCluster ran in another vCluster, right? And then people are like, oh. Yeah, I wouldn't go too deep though.
There are like 7, 9 more questions, but I think let's just take this one. Okay. It's about resource restrictions. So how do you keep your vClusters in order or in control?
Yeah, so ultimately the resource restrictions for vCluster, again, it's just a pod running in a namespace, right? So however you're limiting a regular pod in your cluster, namespace-based multi-tenancy, right? You have resource quotas in place. They'll obviously be restricting the vCluster itself, as well as any workloads running alongside the vCluster. So pretty standard. One thing you can do in the, so we do have the commercial offering of vCluster, vCluster Pro. One thing you can do with that is you can have a vCluster in one cluster, like the control plane, but then you're actually syncing the pods into a different cluster, right? Or a different namespace in the same cluster. And that's really interesting because that way you can kind of divvy things up even further and you can say, hey, we as a platform team ensure the uptime for these vClusters. So we don't want any tenant workloads and vClusters run alongside each other, right? There's a couple of cloud providers, obviously not the really big ones, but like the, tier 2 and 3 cloud providers using us to provide like managed Kubernetes offerings ultimately. And for them, they guarantee the uptime for their customers, right? So they have to have the vCluster definitely running in a separate cluster, and then the workloads run in different clusters.
All right. Thank you very much, Lukas. I think you are going to be around for more questions if people have more. Please give him a hand. And thank you.
Awesome. Thank you.